Hi guys, and welcome back. So let's go ahead and wrap up this mini unit on compound interest. So this is our third video in the series, so please make sure you watch the earlier two videos. But a quick summary, there are different ways to calculate interest. One of them is simple interest and the other one is compound interest. Depending on how often the interest is compounding, that will determine which of the two formulas we'll use. If we have a fixed or finite number of compoundings, then we'll use the first one, a equals p times 1 plus r over n raised to the nt power. And if the interest is compounded continuously, then we use a equals p times e raised to the rt power. So let's do this. So it says fun problem. If $3,000 is deposited at 2.5% compounded quarterly, how long will it take for the account to grow to $5,000? Please round answer to one decimal place. In the earlier two videos, we were being asked to indicate what is that final amount. So like the total with principal plus interest. But in this case, we are being asked to find some kind of time. Okay, the problem mentions something about compounded. Okay, so that means that's code for we're going to use a compound interest formula. Then I'm like, which of the two are we going to use? Well, if it says that the interest is compounded continuously, then we use the one on the right. If it doesn't say that the interest is compounded continuously, then we're going to use the one in the left. Compounded quarterly, that does not look like continuously, so we're going to use the first one. Okay, so let me go ahead, write out the formula. So we have a equals p times 1 plus r over n raised to the nt power. Then I'm going to write out the facts. Okay, so we have, if $3,000 is deposited, so our principal is $3,000. So principal, what is that? It's the money that you invest, deposit, or borrow. If $3,000 is deposited at 2.5%, so the rate is 2.5%, compounded something. So compounded, that's code for n equals. So n is the number of times that the interest is compounded or paid out per year. Compounded quarterly, that is code for interest is paid out 4 times a year. Fantastic. So we got to do a little detective work. The popular mistake is that students, when they see quarterly, they may be inclined to put like n equals 25, and I'm assuming because it reminds us of 20, like a quarter, which is 25 cents. But if you break it down, like the reason why it's called a quarter is because it's just 1/4 of a dollar, or like a quarter of a dollar. But yeah, too much information. All right, so interest is compounded quarterly, so that's code for interest is paid out 4 times a year, so n equals 4. The question is, how long will it take for the something? How long? That's my time. T equals, I have no idea. Whenever I'm being asked to find something, I'm in the habit of saying variable equals I don't know. How long will it take for the account to grow to $5,000? So the final amount, principal plus interest, it should be $5,000. So that will give us that A equals that. Okay, so let's go ahead, plug and jug. So we have that the final amount, principal plus interest, should be $5,000. But I never wrote it out for you. Sorry, I'm a little nervous. So the principal is, let me write them in the order that we found them. The principal is $3,000. The rate is 2.5%. While we're at it, let's put it in decimal form. The interest is compounded quarterly, or is paid out 4 times a year. How long? What is the time? How long will it take for the account to grow to $5,000? So the final amount should be $5,000. Yeah, sometimes I get a little bit excited and go straight to like crunching it in, but then remember, we want like a solution manual, not an answer key. So we want to write down everything. So we have that the final amount is $5 grand. The principal, where am I, is $3,000 times 1 plus r. R is 2.5% or 0.025 over N. The interest is compounded quarterly or 4 times a year, raised to the NT power. So we have N is 4 and T is, I have no idea. Now, what kind of equation is this? You know, same speech. Is it linear, quadratic, so forth? We notice that the variable is located in the exponent area. So it's the exponential, it's an exponential equation. So when it comes to solving exponential equations, we usually ask ourselves, can we fix it so the left side and right side can be written in terms of the same base? I don't even know what this base is, so let's go ahead and simplify. So we have 1 plus 0.025, and instead of hitting the fraction button, we're going to hit the division sign, divided by 4, and that gives us 1.00625. Please don't round, okay? We only round at the very end. Okay, so we have 5,000 equals 3,000 times 1.00625. I think it's a 5, yeah. Raised to the 4t power. Now, my next goal is to isolate the base. Okay, so I want to isolate this 1 point something. Okay, so to get rid of this times 3,000, let's go ahead, divide both sides by 3,000. That's one of our properties of equalities. I think that's 3,000. Okay, cool. And I hate reducing. It takes a while, so I'm just gonna go ahead, punch it in, and write the decimal equivalent. So we have 5,000 over 3,000, and that gives us something not so nice. We cannot round. I mean, if you want to put the repeating decimal, go for it, but how are you gonna enter the repeating decimal? So we're just gonna have to round it. Okay, let's do this. So the quotient of 3,000 and itself on the right side cancel out. Now I'm going to go ahead, bust out a thinking area in terms of reducing 5,000 and 3,000. I know you could do it in your head, but I really can't. Top and bottom has like 3 zeros at the end, so let's go ahead, reduce by 1,000. Many students are like, we'll just cross out the zeros because that's how we were taught. I mean, it's fine. You can do whatever you want, but again, I love myself, so I want to show my work. Okay, so when we reduce by 1,000, that will give us 5 on top, 3 on bottom. There's no more numerator and denominator don't have any factors in common other than 1, so we're good. So thanks to our hard work, the left side simplifies to 5/3 equals this cool number raised to the 4t power. Okay, we have already established that we have an exponential equation. Okay, so in this case, we would like to ask ourselves, can I fix it so the bases are the same? The answer is no, because 5/3 does not look like that. Okay, so 5/3 does not look like that. Okay, no, we cannot easily fix it so the bases are the same. So when that's the case, we're gonna take the logarithm of each side. You can take the logarithm base, whatever you like. You can take the log base 5/3, log base 1.0625, but you know what? Love yourself and just work with what your calculator has. Just take either the common logarithm, so the log base 10, or you take the natural logarithm, which is the log base e. I'm gonna just take the regular log base 10. So let's go ahead, take the logarithm of each side, base 10. So we have logarithm base 10 of 5/3, but there's no need to highlight the base. If the base is the 10 or the common logarithm, we don't write it, so there's no need to announce it. So we take logarithms of base 10 of both sides, and that will give us whatever that will give us. Cool. All right. At this point, we are going to use the power rule for logarithms to bring the exponent down. So the variables, I may say a little bit different, but it's okay. It's more of the understanding. So we have logarithm base b of x to the r. And depending what book I'm using, then I'll use different variables. But the power rule for logarithm says this. wouldn't it be nice if we could tone down the argument? If we can just take the logarithm of x instead of saying logarithm of x to the r power? Well, we can, okay? So when we use the power rule for logarithms, we're going to take the exponent down and then multiply it by the leftover logarithm. So it'll be log base b of x. Okay, so we're going to use the power rule of logarithms on the right side. So we have log of 5/3 equals, let's use the power rule on the right. Okay, we bring the exponent down, so that will give us 4t times the leftover logarithms. Now these lowercase l's with tied i's can easily be confused with ones. Look, what's the difference? They look the same. So I'm going to switch it up to uppercase L. So we use the power rule to bring the exponent down and then multiply it by the leftover log, which is just going to be that. Log of 1.00625. Hopefully I copied it correctly. Cool. So now how are we going to handle it? So in this case, I want to get rid of the times 4 and the times log. To get rid of the times 4, we're going to go ahead divide both sides by 4. To get rid of the times log, we're going to go ahead divide both sides by the log. So all together, to get rid of the times, 4 times log of 1.0625, we're going to divide both sides by those two factors. Divide both sides by 4 times log of 1.00625. Okay, so we have 4 log of 1.00625. Fantastic. So on the left side, let's just write down what we have. We have log of 5/3 over 4 log 1.00625 equals, on the right side, the quotient of 4 and itself will give us 1. The quotient of log 1 point something and itself will give us 1. So that will leave us with the desired variable isolated. Now, if you were going, like if you were walking down the street and I say, hey, how long is it going to take for something? And you say, oh, it's going to take exactly log of 5/3 over 4 times log of 1.00625 years. I'll be like, talk to me in English, okay? So let's go ahead, use our calculator and round it to, I think it's 1 decimal place. So we have log of 5/3. We're gonna enter the 5/3 as a division problem. 5 divided by 3. Let's close the argument. Fraction bar, hit the division key, divided by 4 times this log. We need to divide the log of 5/3 by this product. So since we're going to divide it by more than one thing, you're going to have to wrap it up. So let's go ahead to open the numerator or open parenthesis. 4 times the logarithm. You don't need the times sign. It's just force of habit. Okay, it's just to remind me that, oh yeah, I'm multiplying these two. But with or without, same answer. Okay, 4 times the log. It opens the argument of 1.00625. Okay, depending on your calculator model, you may see the entire expression, but as you can see in mine, you can. We're gonna close the argument, cool, and then we're gonna close the denominator. Okay, so we had 2 open parentheses. We need 2 close parentheses. Hopefully, we punched it in correctly. And if you want to write down the calculator keystrokes on the side, be my guest. Okay, and that gives us about 20.5. Okay, so I'm just gonna put an extra decimal, so we have 20.4. One more to help us round, and to 1 decimal place, we're gonna look right next door and we will be rounding up, so that will be 5.02. So in this case, the question says how long, well, that looks weird, I'll just write it out. The question says, how long is it gonna take for that $3,000 to grow to $5,000? Under those conditions, it's gonna take about 20.5 years. Okay guys, that's my time until the next one. Thank you.